welcome back. So, in last lecture we discussed about the relation between the carrying capacity and the discharge and its effect on the erosion. Now, channel pattern basically, if you see, it will vary during the monsoon season or during the flooding state. Now, this is what has been shown, the channel depth and the shape of the channel as well as the during the low flow, mean annual flow, bank full flow, and finally during the moderate flood. And this is an example of San Juan River near Bluff, Utah, which shows that at different stages the shape as well as the depth of the channel changes. So, on September 9, which has been shown here, 1941, the river was having the normal depth. With early water rise during 15 September, sediment from upstream deposited to raise the channel bottom. So, the channel bottom was been raised as well as because of the more supply of sediment. Then as water rose further to its maximum level, and this was during October 14, which has been shown here, the channel eroded to its deepest point. So, it went right up to this one. So, this whole what you see is the boundary of the channel pattern which changes. So, it eroded up to the deepest point. So, more amount of water, more erosion, and the channel was deepened. Now, on October 26, the flood level went. So, reduction in the flood level, sediment again deposited to raise the channel bottom. So, the deposition raised the channel bottom and more water eroded and deepened the channel bottom. So, these are the different stages which shows that how the channel changes during flooding state. Even if you see here, the discharge increases. So, during the lower water or the low water stage, the discharge was 18 cubic meter per second, whereas here 185, then increased to 1600 and then reduced to 500 cubic meter per second. So, this shows that channel fill back in as flood recedes. Now, actually if you look at the streams, mostly we have two type. One is what we can term as a gaining stream and another is the losing stream. So, in wet climates, groundwater, because this recharge of the river bed or the river channel will also have the contribution from the surrounding groundwater which is flowing or the groundwater which is getting recharged from the percolation of the precipitation or the rainfall. So, in wet climate, groundwater flows into gaining stream. So, mostly the gaining stream conditions will be seen in the wet climate, ensuring year round flow. So, you will have the perennial channel, whereas in the dry climates, water from stream feeds the groundwater. So, what will happen that you will have the flow in dry climate for some time, and this will the water into the channel will help recharging the groundwater. This losing stream may dry up between rainstorm. So, during one's rain spell, you will have some water in this, but this will recharge the adjacent aquifers. Hence, after the rain, this channel will dry out, termed as losing stream, whereas this one in the wet regions mostly you will have the gaining stream. So, water will remain throughout the year. So, please remember this, the difference between the gaining stream and the losing stream. River and related landforms, if we take natural landscape, then mostly what we see is the active floodplain, as I was showing in one of the aerial satellite photograph of the Indo-Gangetic plain. So, we have the active floodplain where we have the channel which have tendency to move, and this is the boundary of the active floodplain, and the main channel has been shown here. High flow channel are been seen here. So, during the high flow, this channels will be occupied, and then what we see in the associated surrounding or the nearby area within the active floodplain are the wetlands. So, mostly you see the main channel and the channels which are been occupied during the flooding state, that is in high flow state, and then within the active floodplain we have the wetlands also. Now, this is in the natural state. This type of configuration you will be able to see, but suppose you try to channelize the river, that means you artificially do some construction along the channel, then what will happen? Then what you have done is you have channelized the flow. So, actually you have tried to construct what we say the levees on the side of the either banks, and you have utilized the floodplain area for settlement, and this is a very common practice in most of the countries, even including India. We do that, but we never construct the levees, but in some countries this is mandatory. So, what it helps, this portion definitely will be lower than the levees, and this boundary has been constructed so that during the flooding state no water spills over this one. But in most of the cases what has been experienced, that if there is a breaching of this levees, then the low lying areas which are utilized or the which where the floodplains and utilized for the construction will be inundated. So, now what we have here is we have all floodplain, main channel, high flow channel, and then we have the levees. Then because we have utilized this floodplain, and floodplain are the fertile land which people will start using for farming. So, we started having the farmland, and within the active floodplain we have the wetlands. So, this two components we have added here. One is the earth levee and the farmland. So, landscape after the construction of levees, artificial levees. So, advantage of artificial or the natural levees are you can have the construction, or you can utilize the area close to the floodplain which is fertile land. So, this shows the active floodplain and the levees which helps. So, as I was talking that this is slightly elevated portion and which slope downs away from the channel towards the floodplain area. So, these are termed as levees. So, the main channel of the river has coarses gravel at the bottom over here. So, this is the bed load mainly, and then you will have the suspended load over here. Grading to finer grains above. The natural levees are still fine grain, settle out in shallow water. So, this will be mostly the fine grain landform which is formed as compared to the channel bottom, and the floodplain consists of very fine grain mud or silt or sand. It's almost still water during the floods. House built on natural levees along the channel. This has been shown here in B. The houses are been built here. So, this land has been occupied and utilized. So, you will have houses as well as the farmlands. So, this has been used for the settlement. Now, another important landforms which are associated with the fluvial system is the alluvial plain, alluvial fan and delta. So, alluvial fan mainly is the landform which comprise of loose sediments. It may be coarser as well as finer, but mostly what we see is the debris flow comprised of the coarser deposits, and when there is a deposition close to the front or the hilly region and the plain areas, and the shape of the landform is like a fan. Hence, it has been termed as the fan shaped landform comprised of loose sediments. So, alluvial fan, when a stream flowing through a steep valley in upland area debouches suddenly onto a nearly flat valley or an alluvial plain. So, in this case, the best example is the Himalayan range front and the Indo-Gangetic plains. So, when a river debouching into the Indo-Gangetic plain areas, the valley slope changes, because when it is coming from the Himalayan region or the range, then it has the steeper slope and it reduces to almost flat in the alluvial plains. So, this will result into the formation of the alluvial plain, and this happens because the channel experiences a decrease in slope from the steeper to very shallow or low angle. So, the gradient decreases and corresponding drop in velocity will be experienced, and a decrease in the ability of the carrying capacity. So, decrease in slope will drop the velocity and also will affect the carrying capacity, and this will result into a sudden dumping of the material. So, as a result, the stream deposits its load. So, it will dump all the load which it was carrying from the steeper slope onto the flat surface, and it will be deposited in the form of, the shape is like fan, hence called as alluvial fan. So, most of the mighty rivers, this is a picture or the satellite data of on 3D perspective view of the Indo-Gangetic plain and the Himalayas, which has been seen here, and this city which is in Chandigarh city. So, what we see is the upper Shivalik hills or sub-Himalayas, the Yangad mountain chain, and the contact between the Indo-Gangetic plain and the hilly range, the Himalayan range. So, youngest mountain range of Himalaya, and the contact between these two marks the geomorphic boundary, and this geomorphic boundary plays an important role in the formation or the deposition of the material here, resulting into the formation of the alluvial fan. So, most of the streams which are flowing here at the base have deposited or dumped their material because of the change in the slope from steeper to shallower, and resulted into the formation of alluvial fans. And this shape here which you see, the boundary, which is roughly I can mark because it is already disturbed by the construction, is your alluvial fan by Gaggar river. Now, fans are typically seen at the slope or the breaking slope where the rechannels, if you see in the previous slide, it shows that what is happening here, that we say that the channel is confined in the hilly areas. So, this is the confined channel, but when it comes and the slope is also steeper, so when you flow the water from the confined conduit and try to allow the water to flow on unconfined surface, then it will spread out, and this is very much similar to the distributary network which will be developing here. So, multiple channel will result into the formation of the alluvial fan. So, deposition fan. Now, the hazard which is related to this is the closer to the front, that is the proximal part, will have higher hazard, and as you move away from the front, mountain front, then the hazard will reduce, and this is mainly because the energy conditions will be much higher here. So, if you say the energy condition is much higher here because the stream or the channel is debouching from the steeper slope to the lower slope, and this will result into the dumping of the coarser material. So, the hazard is much higher here, and as it moves further downstream, the carrying capacity decreases and it will carry mostly the finer deposit. So, velocity also decreases here and it will deposit, it carries finer deposit as well as deposit the finer material here. So, in terms of the hazard, it has the higher hazard or close to the front, and it reduces, the hazard reduces as you move away from the front area. So, same what we see, this is the proximal part, and then we have, this is the shape of the alluvial fan. Now, this is a picture of again the satellite photo of the Himalayan range and the Indo-Gangetic plain. So, the color tonal variation of if you see, and the carving of the landscape or the landform or the surface of the earth, which can be seen over here, and these are all small drainages, and the small drainages here as well as the major channels which have sculptured or carved or eroded the landforms or the landscape and resulted into the formation of different landforms. Now, this is the contact between the Himalayas and the Indo-Gangetic plain, and as I was talking about that, the channel remains confined until this point, and as soon as it debouches onto the flat surface, it is divided into multiple channels. So, close by channels have resulted into the formation of the coalesced alluvial fan, and all the channels, if you see, you will be able to find that there are alluvial fans which have been formed at the base of the mountain front. Even this is in wide one, and this exists like this. Okay. So, there are multiple alluvial fans which have been seen close to the front, and this will happen whenever there is change in the slope, that is from the hilly areas to the plain areas. So, this is one of the best example. So, it depends on the drainage basin, because these are the small drainage basins, or the drainage system are smaller in terms of their area, which originates from here and just flow down to into the Indo-Gangetic plain. Hence, it has deposited or resulted into the formation of smaller fans which have been seen here, because this stream originates here and get debouched into the Indo-Gangetic plain over here, resulting into the formation of smaller fan. And the mighty rivers like Ganga, Brahmaputra and all that, they have deposited larger, covering larger area and larger alluvial fans. We will see one in coming slides. So, further, alluvial fan are fan shaped deposits of water transported material or alluvium. They typically form at the base of topographic break or the topographic feature, where they there is a marked break in slope from steep to shallower. Consequently, alluvial fan tends to be coarse grained, especially at their mouth, that is the proximal part, and at their edges. However, they can be relatively fine grained. So, close to the mouth, they are, or we can say the proximal part, they have the coarser deposits, and as you move further downstream at the edges, you will have finer deposit. This is the term which has been used for the area, that is pediments, a sloping surface at the base of the mountain formed due to erosion. So, this portion basically is termed as pediment area, and it is covered by thin veneer of alluvium. So, mainly it is formed due to erosion along the sloping surface or the base of the front, mountain front. So, we were talking about the alluvial plain, alluvial fan and the pediment. Now, this is the crust of the hills and the free face scarp, or you can say the slope, steeper slope along which the river will get into the or deposit into the shallower slope in the alluvial plain. And the portion where the deposition is taking place comprised of debris material is termed as Piedmont zone. So, one is pediment. Pediment is erosion, whereas the Piedmont area is basically the depositional portion, where it comprises the coarser debris at the base of the mountain front. So, this case you can say that this is the contact between the Indo-Gangetic plains and the Himalayan front. So, the area of deposition developed adjacent to the Himalayan foothills, mainly by stream debouching onto the Indo-Gangetic plain with coarser debris. So, please remember about the Piedmont and pediment. Now, coming to the deltas, when a stream enters the standing water of the sea or lake, its speed drops rapidly, its ability to transport sediment decreases, and it deposits the solid load. So, this is very much similar to what we were talking about when there is a change in the gradient from steeper slope in the hilly terrain and debouching onto the gentler slope in the plain areas, the alluvial plain areas. So, similarly, where in terms of the formation of delta, again it is the channel is, or the river is going and meeting the ocean or the water body. Again the slope changes, and change in the slope will also affect the carrying capacity. So, it again debouches, but here deposit the material or dump the material similar to what we have seen in the alluvial fan region, but the location of the formation of these two landform is different. One, it is at the base of the mountain front, and one where the channel goes and meet the ocean or a water body. So, a fan delta typically is built adjacent to the mountain front, where it comes in contact with the ocean or a water body, whereas the braid delta is coarse grained delta constructed by a braid stream that builds outward into a standing body of water. So, these are the examples which are been shown here, that one you have the fan delta which are close or adjacent to the mountain front. Another is braid delta which have more distributaries or distributary channel And then third one, what has been shown here is the shape of the delta, where the distributaries are less and they are comparatively fine grained, whereas this braid delta will be coarse grained as compared to the bird foot delta. This has been termed as bird foot delta, and they are mainly the fine grained delta. And the best example of this delta you can see or experience is in Kutch region, where the ancient settlement used to be there, or the presence of the olden settlement was along the bird foot delta. So, the deltas, many of the world's largest streams have built massive deltas at their mouth. One is Ganga, Brahmaputra, Yonghi, Yellow River, Amazon, Mississippi. So, mainly the distributaries are long, finger like channel that branches from the main channel in a delta. So, this is one of the largest delta. So, close to the hill front, basically the shape of the landform is like triangle, hence it has been given the word, it comes from Greek letter, it is termed as delta. Formation of delta in a close water body. So, one of the largest delta in the world, the Ganga and Brahmaputra river combined have formed one of the largest deltas in the world, which covers almost 1 lakh square kilometer region. The Ganges river originates near the Tibet and India border and then flows southeast across India to combine with Brahmaputra and resulted into the formation of delta. Now, this delta of course is the region of Sundarban, and if possible I will give one lecture on that, how the settlements got affected because of the change in climate and losing out the channels or the water in the channels in past. It is not very old story, but it has happened in Gujarat, the great run of Kutch, which has dried up. A lot of well urbanized settlement were present in the delta complex of what we call the ancient Saraswati. We have named it as an Paleo delta complex of ancient Saraswati or Paleo Saraswati. And this portion which I am talking right now, the Ganga Brahmaputra delta, is also under threat, because if the sea level changes here or there is a sea level rise, the elevation of this region, that is in Sundarban, is not very high from the mean sea level, and the inundation will be sure. So, it is going to affect the habitation here, and lot of area will be lost because of the increase or rise in sea level. So, I will stop here, and in the next lecture we will discuss about the alluvial plain and the formation of the alluvial fan by Kosi river and its complications. So, we will talk in the next lecture. Thank you so much.